Let's talk about for all versus there exists. Now, after the word for all, there's usually a lot of additional text that appears. Same, right after there exists, there's a lot of text that appears. So in this video, I'd just like to really talk about and clarify what the heck for all means, what the heck there exists means. And I think with the right kind of example, you already kind of have been through this, and I think you're going to be okay with what's being said here. But I just want to make sure to say some stuff so we're all on the same page. And then in the next video, we'll talk about how to prove and how to use a for all statement, and we'll also talk about how to prove and how to use a there exists statement. But first, before talking about how to prove and use these things, we better just be clear about what these things mean, right? And these things often can get confused for one another. That happens. So I just want to sort out some things and make sure to get a couple warnings, friendly warnings in place so that we have some good habits. Okay, so for all versus there exists. Just to make this discussion work, let's just say that capital S for now is the set of all the students at all universities in the world, right? So you should be a member of this set, right? So this set actually is not a set of numbers, but it's rather a set of humans. Each element of the set is a person. It's a person who happens to be a university student. Okay, now let's consider the following two statements. The first statement is for all x in S, for each person who is a student at a university, the student X has a television. And then the second statement is there exists an X in S such that the student X has a television. Now, these statements don't say the same thing, right? It's not that we can go survey every university student from every university all around the world, but really, come on, the for all statement's got to be false. It's not conceivable that every student at every university around the world has a TV. I mean, there's probably even some at your own school that don't have a TV. That might even be you. Now, what about the statement there exists a student at a university, right? There exists a university student that has a television. That's got to be true. I mean, it just only needs to happen once, right? So clearly, these two statements are not saying the same thing, right? For all and there exists are not the same thing, right? So do not read a for all and think it's a there exists statement, and similarly, don't look at a there exists statement and just think that it's a for all statement. That would be a mistake to do, right? You can't just switch one for the other. They're different statements. As an analogy, treating these two as if they're just the same, as if you could just swap one for the other, would be about as silly as saying that 3 plus 5 and 3 times 5 are the same, right? Plus and times aren't the same. Let's look at another example to help really dig into things. This one may look a little more typical in terms of its mathematical language. We'll just use P of y to be the statement y squared is less than 10, and we'll have T be the following set. So T is now a set of numbers, just has the whole numbers 1, 2, 3, 4 in it. So let's take a look at for all y and t, P of y. That is, for all y in this set, maybe little y could take on the value 1, 2, 3, or 4. Y squared is less than 10, right? That's what could replace this right here. So another way to write this, because this is for all, like this is supposed to be true for every single element of t. Every element of t, if we just call it y for a moment. Another way to write this entire statement right here can be written without the for all at all. Instead, it could just be p of 1 and p of 2 and p of 3 and p of 4. And by the way, that statement has to be, it actually ends up being false because p of 4 is false. You'll see that p of 4 is supposed to be the statement 4 squared is less than 10, which is false. Now there exists y and t such that p of y, this can be written p of 1 or p of 2 or p of 3 or p of 4. And this statement is true, right? We just need one of these four statements to be true. In fact, p of 1 is true. We don't need to check the other ones, but p of 2 happens to be true. P of 3 happens to barely be true. 9 is less than 10. So you see, the thing is, for all, it's really about multiple uses of and, whereas there exists, if you break it down to write it a different way, it's really about multiple uses of or. Or let's look at this. Here's an analogy, right? So summation notation, sum of things of the format 1 over j squared. J goes from 1 to 4. That can be written 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared, right? So a summation symbol is just a multiple plus thing. And so that's the analogy. And just like summation is a repeated plus, for all is really a repeated and there exists as a repeated or. I think this puts some additional reasoning behind why you really just can't take a for all and a there exists and just treat these as if they're both the same. And actually, there's another important lesson hidden in here. If you see for all y in t, p of y, so this thing right there, don't think that it's there exists y and t such that p of y. So we've discussed that issue. But okay, so that's not a new warning. But here's an additional thing. Don't think that this is just p of y alone. So if you see this statement, um, what what sometimes students do is they'll see for all y in t p of y and just think that it's p of y alone. Like they'll just kind of conveniently try to ignore this part. You cannot ignore the for all y and t part because then it's ambiguous whether it's this or that if you just leave it out altogether, right? So this would be the analogy is this would be thinking that this right here is just the same as this right here, right? These aren't the same, right? There's no communication of what's the last value of j, this 4, right? So I mean 1 over j squared itself could have a meaning, right? It's just, hey, this is just 1 over something squared. We just don't know what the j is, right? Like this, you see this in an algebra class. This can make sense on its own. And then, when you're taking that part of calculus where you're talking about series, this is an entire sum of all of these things added together. And this is kind of right here trying to, this 1 over j squared is trying to just generically talk about just maybe one of these 4 terms, right? So you got to be really careful, that you can't just leave out this summation symbol, right? It's not optional. And so same deal right here, right? So, and part of this is because, when it comes time to talking about proving a for all statement or using a for all statement and proving a there exists statement and using a there exists statement, they're all done differently. So you can't just treat this entire thing right here as if it's just that. And the same kind of warning should really be replicated for if you see a there exists, don't think it's a for all, and don't think it's just the p of y, that part of just the part that's in square brackets alone. But ran out of room to state that warning again.